Rapport Training Consulting. I've been thinking about this idea for several years, and it's probably something I should have known, and it was a surprise to me. So I figured there's people out there just like me that might be a surprise to you. And so my question is, do objects that have the same perimeter have the same actual area? My hypothesis is that two objects that have the same perimeter or circumference or distance around it would have the same internal area. For example, a square with a perimeter 8 and a circle with a circumference or perimeter of 8 should result both equating the same area. That's what I thought. Well, let's check it out and see if it's true. So here's the area of a square and side by side. So you take, in my square is 2 inches, say, by 2 inches. So it has an area of 4 because side by side is the area. And the perimeter is 8 because 4 times 2, 4 sides, 2 inches each. So we have 8. And here I got a perimeter or circumference of 8. And in order to find the area, I had to find the diameter. So that's the equation here, is that area equals pi r squared, and the circumference is equal to, or the diameter is equal to circumference divided by pi, or 8 divided by pi. So the diameter is equal to 2.5465. And since the radius is 1/2 of the diameter, we divided it by 2 and came up with the radius equaling 1.2732. So the area is equal to pi times 1.2732 squared for the circle. So let's compare the. So here's the calculation. And we already know the area of the square is 4. And we find that by putting in the radius, pi r squared, a equals pi r squared, we come out with the area is actually 5.09 versus only 4 for the square. Interesting, isn't it? So always order your pancakes by the perimeter. Conclusion. Objects with the same perimeter does not mean that they will have the same area, and in a lot of cases rarely do. Now here's an easier one. That was what I first came up with. And then I found this idea, and here are two objects that are, I think, easier to visualize. On the blue, you can see that it's 4 objects long by 1 object wide, and if you count the sides, you have 10. And there's the green one, and it's 3 long by 2 wide, and if you count the sides, there's 10. So again, the area of a rectangle is side by side, so in the blue area, it'd be 4 sides by 1, 4. Green area is 3 sides by 2, so you have 6, so they're not equal, same perimeter. And if we threw that into our circle, we'd have an area of 7.95. Here's just interesting, is that if you actually take those objects from the blue and place them into the green, you see that there's actually 2 objects larger. Still, again, I think this is I don't know why, but it's mind-stretching to me that 2 objects of the same perimeter. And I'm sure there's rational explanations. I looked for some online, and they all got very technical, and they didn't explain kind of like the rationale behind it. But just know that if you're going to order anything by perimeter, you want in the largest area. You might want to sit down and see how that's being given to you, because a perimeter does not dictate that it's going to be the same area regardless. Anyway, appreciate your time, and hope you had fun walking through this. If it did remind you, or it was new, or just information that now you can share with somebody else. But I'm with Rapport Training Consulting. Just remember, just because perimeters are equal doesn't mean the areas are too. Bye-bye.